Hello, happy Tuesday. I know there's a game tonight, or potentially a game tonight if it hasn't rained out yet. I'm not sure. It is still the morning for me. So hopefully the Astros have come through for us, or they're still coming through for us maybe right now. But we're going to get down to some algebra. I know you're excited. So tonight we're going to be talking about direct variation, and let's do a little review. So let's recall that a linear equation in slope-intercept form, so when I say slope-intercept, that's your good old y equals mx plus b. And the linear parent function, which is what we learned last night, is y equals x. Remember that? Okay, so this is the last lesson in this unit. Then we'll review in class on Thursday, and then you'll have a test on Friday. All right? So the direct variation is a special type of linear equation of the form y equals kx or y equals a of x, ax. And I'll explain what these are in just a second, okay? But let's get these definitions in first. What direct variation does is it represents a proportional relationship. So if you remember in 7th grade and you were building your way up to slope and you learned k equals y over x, you know, the constant y over x. Well, that is linked to this guy. And this was all about constant of proportionality. So these formulas here that I just told you, direct variation, that's where we get that proportional relationship. It's from that constant of proportionality. Remember, we had to find a constant. And what that really went into was rise over run on slope. So let's look at some examples of a direct variation and graph them all on the same coordinate plane. So here's an example here, y equals 2x. It's in this form here, y equals number before an x. Okay, so let's graph that one first. There is no b, so we're going to start at 0, 0. This is going to be the one I'm going to do in blue here. And what is the slope here? 2 over 1, right? So we're going to go up 2, rise 2, over 1, rise 2, over 1, rise 2, over 1. Okay? And on the same side, we could go down 2 into the left 1, down 2 into the left 1. And then we would just draw our line. So you should be getting some good practice in plotting a line from slopes. So this was number 1, example 1, y equals 2x. Let's go with green for example 2, y equals a negative 3x. Okay, so just think about it. What do you see here? Is this slope positive or negative? It is negative. So this line is not going to be going up like this. It should be going down. It's a negative slope. Let's see what happens. Again, it doesn't have a b. We're going to start it at 0, 0. We're going to go down 3, 1, 2, 3, and over 1. Down 3, 1, 2, 3, over 1. Down 3, 1, 2, 3, and over 1. It looks like this. This is number 2. Our third line over here, I'm going to do in pink, is a little bit trickier. Not really. It's just a slope. The rise is 1 and the 2 is the run. Okay? So this one also starts at the origin. And you're going to go up 1 and over 2. 1, 1, 2. Put a dot. Up 1, 1, 2, put a dot. Up 1, 1, 2, put a dot. And so on. So this one should be a positive slope, positive line, because it is a positive slope. So yes, it is. It is a positive slope. All right, so now that we've got those plotted, let's look at them all. What do you notice is the same for all three graphs? What do they all have in common? Look at where they start. That's a hint. They all pass through the origin. Okay? All of them have a b that equals 0. That is something they all have in common. All right, what is different about all three graphs? What's different? Well, the slope. The slope is different for all three of them. So in the equations, y equals kx and y equals ax, which is what we just had, kx and ax, the k is referred to as the, I told you this earlier, remember from this formula here from 7th grade, is referred to as the constant of proportionality. The constant of proportionality. And the a is referred to as the constant of variation. I like to remember that the a is the constant of variation. A. All right, what's another word we might call k or a? Where is the, in each of these formulas, y equals kx and y equals ax, it comes before the before the x. So what else do we know always comes before the x? Say in this equation. Yes, it's the slope. It's the slope. We also might have it called the rate of change or the m. Okay, all three of those things refer to the slope. So if you solve the equation y equals kx for k, then k equals, I told you earlier, y over x. If you solve the equation y equals ax for a, like if you were to move everything around and get what it equals to a, you would get y over x. So tomorrow in class, we're going to get out our calculators. This is going to be our warm-up. And you're going to decide the following are direct variation functions. If they are, then they state the constant of variation. If they are not, then explain why. Okay? So tomorrow you're just going to graph these in your calculator, and we'll talk about those as we do our warm-up. All right? Have a good night.